All right, good afternoon. Welcome to section 10.5, and here you will see the beginning of what this section is about. Take a moment to read this. I'll read along with you, where it says, often in mathematics it is helpful to write a radical expression such as square root of 3 divided by square root of 2, either without a radical in the denominator or without a radical in the numerator. The process of writing this expression as an equivalent expression but without a radical in the denominator is called rationalizing the denominator. To rationalize the denominator of the square root of 3 over the square root of 2, we multiply the denominator and the numerator by the square root of 2. Recall us doing that where it is the same as multiplying by the square root of 2 divided by the square root of 2, or 1. Same as multiplying by 1, so you don't change the problem. So here's a little example of what's happening with that. And as you can see, we are, where am I here? We've got the square root of 3 divided by the square root of 2. And then we multiply the top, I got it in green there, the square root of 2 divided by square root of 2, which we then multiply together going across. Then we got the square root of 6, and then square root of 2 times the square root of 2 is the square root of 4. Kind of like an extra step there, but we know the square root of 4, which is a square number, simplifies to be 2. So I can't do any simplifying with the square root of 6, and so this is my answer here. Alright, and that's how we do that. And what this in effect does is, since we're rationalizing the denominator, we're removing the radical sign from the denominator. In higher mathematics, they want you to do that so you can add or subtract these these rational expressions together with the same denominator. Easier to figure out what to multiply to get the denominators to be the same. Okay, and likewise they ask for us to rationalize the numerator as well. So we'll pay attention to what our duties are here and go accordingly. All right, and I will give some examples here now. All right, so let's move on to example 1. Okay, and example 1 is to rationalize the denominator. Example 1, page 712. So I'm going to multiply the top and bottom here by the square root of 5. Okay, when I do, now we're careful with everything we do here from now on out. It shouldn't starting to get a little sticky and complicated. So this is 2 times the square root of 5, which is 2 root 5. Okay, and that's going to be divided by, what's the square root of 5 times the square root of 5? Well, if I did it one extra step here, it's the square root of 25. And we know the square root of 25 is 5. So I got 2 root 5 divided by 5. And this would be my answer I'm looking for. The radical sign is gone from the denominator. Okay, next example. Okay, example 2. Okay, so now when we see something like this, like all these expressions now, by the way, we want to begin by simplifying. Simplify whatever we can and see if we've got a radical left. We're still rationalizing the denominator, so what I want to do here, I want to simplify this. So I see the square root of 16 is 4. So let's see, I already know then the top is going to be 8. Square root of 16 is 4. 4 times 2 is 8. And then I see on the bottom, this is the square root of 9, which is 3. And then what's left over is the x. It's just x to the first power. I don't have 2 of them. So this is my problem thus far. I'm not done yet because I have a radical in that denominator. So again, I want to multiply top and bottom this time by the square root of x. square root of x. Okay, so what does that give me? This gives me 8 times square root of x is 8 square root of x, and that's going to be over, let's see, I got 3 times square root of x times the square root of x is square root of x squared, which is x, so I'll just be left with 3x. Remember, this times this equals x. First of all, I'm going to do it this way again. I'm going to continue, so make sure you got that, what I'm doing here. The square root of x times the square root of x is the square root of x squared. And then the square root of x squared is x. And that's where I'm getting the 3 times x. Okay, and so this is my solution here for that problem. You know, what's nice is you can do this anyway. You could have multiplied the top and bottom by the square root of 9x if you wanted to. And I'll leave that for you to do just to see that you'll arrive at the same answer. Okay, next problem. Okay, here's another one where it is the cube root this time of 1 over 2. And they say to rationalize the denominator. So I'm going to go ahead and split this up. I like to anyway, but I'm thinking, oh, this is the cube root now. Alright, and so the bottom here is going to be a cube of 2. So what I want to do is I want to get a perfect cube down at the bottom, in the denominator. So the radical sign will go away. So that means I must multiply the bottom anyway by, let's see, if this is, I need a cube here. So if this is 2 to the first power, really, I need 2 more 2's so I can cube it. And that would mean I'm going to multiply 2 to the first times 2 to the second. And that gives me 2 to the third power. What I do to the bottom, I'm doing to the top as well. So I'll do it like so. And this is really the cube of, and I can call this 4 here. Alright, so what happens here? When I multiply this across, let's see, I can simplify this. This is 1, and 1 times the cube root of 4 is the cube root of 4. Okay, and then the bottom now is going to be, let's see, this, I'm going to break it down to be the cube root, and I'm going to multiply these guys together. So this is 2 times 4. 2 times 2 times 2 is 4, so that's the cube root of 8. Alright, so there, I've got my cube root of 8 because it's a perfect cube number, and so I'll end up with an answer of the cube root of 4 divided by 2. Alright, like I say, there's different ways of doing this, so you'll probably come across and say, I got a shorter way of doing it, or a lot of things you know in your head from doing these problems already, so you start memorizing them, and that's to your benefit. But this is a breakdown of it, and you get the idea of what we're doing with respect to getting this, in this case, to be a perfect cube number, not a perfect square number as we did the previous examples. Okay, that was example 1, 2, 3, and I don't know. Let's do another one here. Okay, so this is example 4. Okay, so let's see what have I got here. So here's the big fraction underneath the radical sign, so I'm going to split it up to be 7x and divided by the square root of 3y. Let me take a quick look here. That is square root. Yes, it is. So I'm going to rationalize the denominator. So I'm going to multiply top and bottom by the square root of 3y. Okay, so not the cube like we did before, so the square roots are easier because you know you got 2 of them. If you have one here, the other one is the same expression underneath the radical sign. So that makes it a little bit easier. When you get to the third root and fourth roots, then you got to put your thinking cap on a little bit tighter. Alright, so regardless, I've got 3y is this simplified denominator. And then up top, I've got what? 7x times 3y is the square root of 21xy. Okay? And that's all I can do. Remember, you don't want to, you'll be tempted to divide 21 by 3, but we can't because 21's underneath the radical sign. 3 is not. So then that rule is out. We can't do it at that point. Alright, so this is the final answer for that. Already simplified. Next. Okay, let's see what we have here. This is a little bit challenging. So as I'm doing this, I'm looking at the fourth root now of these things. So, let's simplify this a little bit. So the fourth root of x is just the fourth root of x. Keep that with me. And the denominator here, it looks like I could have fourth root of 81. Well, that's the same as the, let's see if I do it this way. I've got the fourth root of 3 to the fourth power, and then this is y to the fifth power. So I could write this up as y to the fourth times y. Could look at it this way. And then continue to simplify this now by writing this up as the fourth root of x is the numerator. Alright, that doesn't change. And then down yonder here I've got, this is nice, 3 to the fourth power, so the fourth root of 3 to the fourth power is the 3. So that comes out front. The fourth root of y to the fourth is y. For every 4 y's you take one out. That's y's, not wives. And let's see, now I've got what's left is the fourth root of y. That's left over. This one here. So put my little 4 here. And my 4 is there. This is the index number here. Okie doke. So what have I got left? Oh, I have nothing left because I still have to rationalize the denominator. All we did thus far is simplify it. So right now I want to multiply the top and bottom by just the radical sign and what's in it or underneath it. So it's going to be top and bottom. I'm going to multiply by the square root of y. Right? Square root of y, top and bottom. So it looks like my numerator here is going to be the, technically this is it. I've got the fourth root of xy, and that's going to be divided by 3y, and then the fourth root of y squared. Y squared. Okay. And that looks like, what else can I do here? No, I take that back. What I want to do here, this is the fourth root I need, so if this is y, I need to multiply top and bottom here by y cubed. Y cubed, this has to be the same. So I'm multiplying this bottom by the fourth root of y to the third in order to get to the fourth root of y to the fourth. So now when I multiply this across, it's going to be what? 3y, that's fine, times 1 is 3y, and then the fourth root of y times the fourth root of y cubed is the fourth root of y to the what? Not squared, but to the fourth. I want that to be to the fourth. So let me get rid of that, mark it up as 4. That's much better. And then the top here I've got the fourth root of x, the square root of x, times the 4th root of y to the 3rd. So that's going to just be the 4th root of xy to the 3rd when I multiply that across. Alright, so now that's looking much better, and now I can write my final answer up as the 4th root of xy cubed divided by, and now I can just simplify this. This is going to be 3y squared, because this 4th root of y to the 4th is y, so that is just a perfect, 4th root. So that just becomes y multiplied to this y to give it y squared. So this is our solution here. Okay, so we'll move on now to rationalizing denominators having two terms. Okay, a little mini lesson here. Remember having the product of the sum and the difference of the same two terms? Remember us having that when we were factoring or multiplying. They came up a couple of times. Well, this is an example of these two expressions here. These two expressions they are what's called conjugates of each other. Conjugates. Okay? So we're going to need that skill when we are rationalizing numerators or denominators when there's two terms in the numerator or denominator. And then we're going to use this here to do our simplifying of that denominator or numerator. Because remember, what is it that we do to do that? Now we want the shortcut way for sure. If you FOIL this, you end up with a squared minus b squared. So the shortcut way of multiplying these two binomials, the conjugates of each other, is by taking the first term and squaring it. There's how we got the a squared. Then taking the second term and squaring it. In this case it's b squared. And then it's always with the subtraction sign in between them. It's never a plus when you multiply the sum and difference of the same two terms. Okay, so it makes for real easy calculating that way. At least it's supposed to. Okay, so let's see. I'll give you an example now. And that would be, how about, well, let's do something a little easier here. How about 5 over the square root of 3 minus 2. Okay, so here it is. It says that it's saying to rationalize the denominator. Okay, so in this denominator I have two terms. Therefore, I'm going to multiply the top and the bottom by the conjugate of square root of 3 minus 2, which is the square root of 3 plus 2. Okay, let me put them in parentheses, get a little more familiar looking form. If I multiply the bottom by the square root of 3 plus 2, I have to multiply the top by the square root of 3 plus 2. Okay? And there we go. So now I see this familiar form similar to this a plus b times a minus b. This is square root of 3 minus 2 times the square root of 3 plus 2. And now I can go ahead and multiply that together again using the shortcut way of saying what is the square root of 3 squared. I squared the first term like I did the a over here. That was a squared. So the square root of 3 squared is 3. The square root of, the second term 2 is squared, which is 4. And it's always a minus sign in between. Okay, so study this one over. It's just like whatever the square root of any number squared equals n. Okay? Alright, so there I go. I've got, this is my denominator, and then my numerator up here is going to be, I'm just going to distribute this 5 times the square root of 3, which is 5 root 3. and that's going to be plus 5 times 2, which is 10. So you can see what I end up with. I got 5 root 3 plus 10 divided by negative 1, which just makes this, let's see how, I don't know how they have it written here. Two different ways actually. They have it this factored form, or make this a negative out front, I guess would be alright too. And get rid of that as far as you're simplifying. Okay. Let me take a quick look there. Yeah, this would be, if you leave it like this, this has to be in parentheses then, without it being distributed. Alright, let's try another one. Okay, this is example 6, and I've got, let's just say, rationalize the denominator. That means I want to multiply the top and bottom by 3 root 2 minus 4. Okay, what I do to the bottom, I do to the top. It's 3 root 2 minus 4. Use your parentheses, because you remember you're multiplying that across. So my denominator here, it's going to be what? Square the first term. What is this? 3 root 2, and I'm squaring it. So that's going to give me 9, 3 squared, right? There's really a 1 here, so it's 3 squared, which is 9, times 2, I'm sorry, square root of 2 squared is 2. That's going to give me 18. Always a minus sign when we're multiplying these two binomials. And then I've got what? 4 squared is 16. Then my top here is going to be 2 times this. Okay, so I'm not going to multiply that out because I see I got a 18 minus 6 here is 2, and I'll be able to cancel this out. So it's 2 times 3 square root of 2 minus 4. Alright, I'll simplify that out again. It's 2, 3 root 2 minus 4 over 2, the 18 minus 6. 2's cancel out, and I'm left with 3 root 2 minus 4. The exact answers. Of course, that's always what they want. Okay, remember it, no decimal answers. Alright, let's see what's coming up next. Okay, moving on here to another rationalizing the denominator. Rationalize the denominator. So I'm going to multiply the bottom by square root of 5 plus the square root of 3. Top and bottom. Square root of 5. Ooh, looks like I gotta do a FOIL job up top. And the denominator, I hope you agree, is getting easier. Alright, so what do I got? Well, let's see, let's do the denominator here. So I'm going to square the first term, which is 5, square the second term, which is 3, and always subtraction in between. And then I'm going to FOIL this thing up here. Square root of 6 times the square root of 5 is the square root of 30. Outside is the square root of 6 times the square root of 3, which is the square root of 18, plus the inside, which is the 2 times the square root of 5, which is 2 square root of 5. This is the part to be careful of, right? Because I wanted to say the square root of 10, but that's not the case. That was the insight. Now last is 2 times the square root of 3. That would be plus 2 times the square root of 3. Okay, so nothing happening here. It doesn't look like on top where I can get these to be the same number under the radical sign. So if anything, you may be able to simplify this, and that would get you what? Let's see, I'll clean this up here. So square root of 30, because there's no simplifying there, plus, let's see, here I can take out what can I take out? A 3, and root 2 is left, plus 2 root 5, plus 2 root 3. Oh, thought I could add those together, but it doesn't look like it. And this will all be over 5 minus 3, which is 2. Okay, interesting problem. Make you do a lot of work for nothing. But that's what would happen with that problem. Okay? Alright. How about something else here? I think that you got the main idea about this. Okay, let's do one more of rationalizing the denominator, then we'll go on to rationalizing the numerator, which is basically the same thing, but I'll go through them anyway. I'm just that kind of guy. Alright, so here I've got, I'm rationalizing the denominator. I see I've got a binomial in the denominator, so I'm going to multiply it by its conjugate, which is 3 root x minus root m. Okay, and we'll do the top and bottom. 3 root x minus root m. Make sure I wrote that problem down right. Yes, indeed. Okay, good. So I like to get my denominator squared away, and that's going to be the 3 root x squared, because I'm multiplying by the conjugate, which is the sum and difference of the same two terms. Okay, so this is going to be, what will this be? 9x, it looks like. The square root, this is 3 times the square root of x, which is squared, which is 9x, and the square root of m here, the square root of m squared is m, and it's always subtraction in between. Okay, nice. So now I'm going to distribute this 2 square root of m times 3 square root of x. So that's going to give me what? 6. And I'm going to go ahead and multiply it because I don't see any possible way I can factor out anything worthwhile here in the denominator. So I've got 2 times 3 is 6, and the square root of m times the square root of x is the square root of mx. Minus, this is this minus sign, 2 square root of m times the square root of m. And that's going to be 2m. 2 times 1 is 2. Square root of m times the square root of m is m. Okay, and that's all I can do with that one. I can't do any simplifying. I can't factor anything out and then cancel it with the 6 or the 2. I could factor a 2 out here on the top, but it's for naught because I have nothing to cancel it with. So I'll let it ride here. Alright. Next up. Alright, moving on here, I skipped example 9. It's rationalizing the numerator, but it's the easy one. I'll let you just kind of go back and take a look at that if that's alright with you. But example 10 is a little bit more involved, where we are rationalizing the numerator now. So if I rationalize this numerator, that means I've got to get a perfect cube number here involved because of that index number of 3. So I'm going to create that by multiplying this numerator with a 3 index, and I've got 1, 2 here, remember, so I'm going to multiply it by 2 to the second power to create that 2 to the third power when I do the actual multiplying. And since I've got an x to the second degree, what am I saying here? X squared here, I have to multiply another x to it to get it to be x cubed. So this will just be x here. Okay, take a good look at that, what we're doing. And then what I do to the top, I have to do to the bottom. Same thing, so it's the cube root of 4x, I'll call it. And let's see what we end up with. Alright, so now it's the numerator we are rationalizing, so I've got a cube root of 2 times 2 squared is 8, and x squared times x is x to the third. Similar that we did in the beginning of the examples. Okay, then on the bottom here I have the cube of 5 times 4 is 20, and x times y, or y times x, is xy. My numerator breaks down and simplifies into a number, which is 2, or the cube root of 8 anyway, and then the x is going to be out because I have 3 of them. And that's all going to be over the cube of 20xy. Okay, so we got that done, rationalizing the numerator. Get a little tongue-tied. Okay. How about one more? I'll try and squeeze it in here. Let me just write it while I've got you. So this one is square root of, get rid of that. Square root of x plus 2, and that's over 5. And this again is saying to rationalize the numerator. So if I rationalize the numerator, since I've got a binomial, I'm going to multiply it by the conjugate, which is the square root of x minus 2. Okay, top and bottom, square root of x, square root of x minus 2. That's better. Alright, so just as we did before, I've got the product of the sum and difference of the same two terms, so I can do that by squaring the first term. Square root of x squared is x. Squaring the second term, that's 2. I'll square that, it's going to give me 4, and it's always a minus sign in between. And then I'm going to multiply this 5 times square root of x, which is 5 root x minus 10. And I can't simplify that at all, so I'll just leave it as such in this form. Okay? Alright, and it's bothering me I didn't do that first one, so let me go ahead. Example 9. I try to take a shortcut sometime, but I just can't do it. It's the square root of 7 over the square root of 45. Okay, so let's see, what are we doing here? I'm rationalizing the numerator. So what I want to do is I want to simplify this 45, square root of 45. So it would be the square root of 7 divided by, let's see, this would become 3 root 5. Okay, just to when I multiply them, it's a little easier. And then I'm going to multiply the top and bottom. Since I'm rationalizing the numerator, I'm going to multiply top and bottom by the square root of 7. There we go. So this becomes square root of 7 times the square root of 7 is 7 over 3 square root of 5 times square root of 7, which is 3 square root of 35. 5 times 7 is 35. And there you have it. That's all. So this is rationalized. You can see I got a 7 in the numerator, and bingo, that's it. All right, so that is section 10.5. And I hope you're okay with that. I hope you do well, or are doing well with it. So, continued success, and we will see you soon.